Hey guys, welcome back to another episode of Reactor Toots. My name is Peter, and did I say reactor? Reactor? We're gonna be taking a slight departure from the conventional synth building tutorials that we've been doing, and go into some more event-charged instrument design. So, kind of aleatoric compositional devices and kind of cool brainy stuff like that. And one popular exercise that instrument builders do is they try to make wind chime simulators, and there's many different ways to build wind chime simulators, um, but nothing. That's a fact. So yeah, let's build one in Reaktor. The easiest way that I can think of to build a wind chime effect is having some kind of engine that uses randomly timed events or outputs randomly timed events going into some kind of sound source and then outputting for us to hear. So there are a couple of different methods to achieve that result in Reaktor. Um, the most apparent method is using a module called Geiger. And we get to Geiger by going to built-in module, oscillator, Geiger all the way at the bottom. And this is used to output randomly timed ticks or vents. So randomly timed audio signals or vent signals, which is very helpful. Give at the given density and consistency from these two parameters right here. So P will control the logarithmic control of the average rate or density of the randomly timed events, and then R&D is how random they are. So a value of, say, like a high value at the P input and a 0 at the R&D input would mean that there would be a ton of events coming at completely random times, whereas a high value at the P input and a value of 1 at R&D would mean that there's a ton of events coming at very consistent times, very regular. So cool. So we're going to use that as our quote-unquote wind simulator, and there are many different far more academic ways at simulating this kind of thing. We could get into chaos and Gaussian distribution and all these crazy equations that are different ways of achieving the same thing, each having their own different result, but we're going to be a lot more basic than that. We're just going to use the Geiger module and then a simple sound source, which we'll just use a triangle wave for now. It's not going to sound like much, but it's proof of concept, which we're going for right now. Right off the bat, let's make some parameters for these. And under the P input, just relabel it to density. Density, because it's just confusing otherwise. And for this exercise, I usually change the range to a minimum of -100 to a maximum of 0 or 1. Just from past experience of doing this thing. So cool. We have a Geiger and we have a sound source. We need a way to basically tune the oscillator, and that needs to be random as well. That's what we're using the Geiger for. Because right now we have no way of telling the oscillator what pitch to play, and we want that note value to be random. Ideally within a fixed tuning, though. So there are a couple of different ways to do this. We basically need a module that holds data for us that we can recall. And it would be cool to use an event table, but I can think of a far more easy method of doing this. So instead of using an event table and getting into that whole can of worms, let's go into signal path and then the selector scanner. And we use this to scan or select between a couple different oscillators in the last tutorial videos, but now we can use this to select and scan between constant values, which is cool. So output the selector into the pitch input of the triangle. Yeah, so the selector object is kind of self-explanatory from the diagram. The input is selected via the pause input right here. And so that's what we're going to try and shoot for, is using the Geiger to modulate the position input between different note values stored in the selector object. Cool, hopefully that makes sense. So for starters, let's create a constant at the first input, and instead of 0, let's give it a MIDI value of 60 to indicate middle C. At least I hope it's middle C. 60 or 64? That's a good question. Let's duplicate, attach, or connect, duplicate. Label that 62, and we're just going to build a major scale. So there we have a major scale going from hopefully middle C to C5 using MIDI values. That took up a total of 8 inputs ranging from 0 to 7. So we have our pitch values. Now we need a way to switch between them. And we have this thing that's giving us randomly timed events, which is great. So we need to make use of this object called randomizer, which does exactly what it sounds like. The input events are modified by a random deviation indicated by the R and G input. So this random value, a randomly timed value of 1 or something, is going to be randomly deviated within the range of here, within the range indicated at the R and G input. And this is going to do 2 things. One, it's going to give us a random value, but it's also going to give us a negative value, or it might give us a negative value. So say a value of 1 came in here, and we had a range of 8. So it'll give us a random number between -7 and 8, I believe. So that means that this value here should correlate with the number of notes we need selected from, or randomly selected from. So let's right click on the RNG input, control constant, or create constant, and then 1, 0, 1, 2, 3, 4, 5, 6, 7. So we need an 8. And the easiest way to ensure positive values is to use math and a math function called rectify, which gives us the absolute value of all numbers that are going through it, which means that it makes everything positive. Going into the position input, and we are almost done. Are you excited? I'm excited. Let's make a small envelope. Attack decay sounds fine. Trigger at an amplitude of, let's just say 0.5. Well, you know what? Let's have it adjustable. Control. Sweet. Control. Put that here. Go over to the panel view. Space everything out. Amplitude. And let's see if we've done it. Okay. I know it's wrong. Oh Jesus. The selector object has a couple of different interpolation settings, meaning that it's the way that it switches between inputs can be modified through a linear algorithm or a sine algorithm. And while it's kind of cool to get some microtonal things from using that method, instead of giving solid numbers or whole numbers, it's just kind of going between these values. And instead of giving us a value of 3, 5, 1. It's doing something more like 2.2, 5.833, and then 1.11. So we need to switch it to none. And then we get lovely equal temperament. Turn the random all the way down to get completely random results. Turn the density all the way down, or all the way up. So now it's more along the lines of a windy day. And there you have it. That's a basic, very basic wind chimey type effect. There's many different ways, or many different things that we could do. Many different things we could do to this instrument to make it a lot more interesting, which I plan on doing in the next few tutorials. So if you have a huge aversion to this topic, if you find that this is dreadfully boring, then let me know and I can go over something else. You can get some really cool results by doing different things to this instrument. So yeah, hopefully you enjoyed that tutorial over. See you in a little while.